Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 12th question from the preliminary exam which was written in the year of 2023 from the St. Mary's School in Waverley. Please do expect a total number of 12 videos since the question paper consists of 12 questions, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam, and most importantly your final examination. So please do share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, the diagram below shows a solid right circular cone that is set centrally within a hemispherical container. The radius of the hemisphere is 5 multiplied by the square root of 6 centimeters, and the radius of the cone is r centimeters. Of all possible circular cones that can fit into the hemisphere, calculate, showing all the working, the value of x, which represents the height of the cone in centimeters, for which the cone will have a maximum volume. Okay. We are told that guys, the radius of the hemisphere is the square root of 5 root 6. This is our radius over there. Our radius is just equal to 5 multiplied by the square root of 6, right? And then we do have the height of the cone. It must be perpendicular to the radius of the cone, right? The radius of the cone is equal to r centimeters. And then we are told that x represents the height of the cone. According to Pythagoras theorem, guys, we can simply calculate the value of radius in terms of x. Remember that, guys, I know that my hypotenuse squared, the hypotenuse is just equal to 5 times root 6 squared. This is equal to r squared plus x squared. Are you together? 5 multiplied by the square root of 6 all squared is just equal to 150, and then I have r squared plus x squared over here. Therefore r squared is just equal to 150 minus x squared. Please guys, do keep this in mind. Okay, we are asked to find the value of x if and only if our cone will have a maximum volume. We are given the equation of a volume there. Nah? This is the volume of a cone, and that's the volume of a sphere. Okay, for the volume of a cone, I know it's 1 over 3 pi r squared multiplied by h. 1 over 3 pi, we do know the value of r squared, right? R squared is equal to 150 minus x squared. That's just 150 minus x squared, and then the value of h, which is the height, we were told that it is equal to x. So I have x over there now. Okay, now all I have to do is to simply multiply out the brackets. Before I do that, let me just make it a bit simple. Let's multiply this thing by x first. I'll end up having 1 over 3 pi multiplied by x into 150 minus x squared, and hence the volume will be equal to 50 pi x minus 1 over 3 pi x cubed. They said we must find the values of x such that our volume will be a maximum, right? So I'm finding the derivative of my volume with respect to x. I'll end up having 50 pi is minus pi x squared. 50 pi minus pi x squared, right? So therefore, remember that guys, my volume will be a maximum if and only if the derivative of my volume is equal to 0. Are we together? So I'll end up having 50 pi minus pi x squared is equal to 0, and then I'm supposed to solve x, right? So I'll end up having negative pi x squared is just equal to negative 50 pi. If I divide both sides by negative pi, then x squared will simply be equal to negative, x squared is just equal to a positive 50, and therefore x is just equal to 5 root 2, because we'll simply find square roots on both sides. So for our cone to have a maximum volume, the value of x has to be 5 times the square root of 2. Are you together? Okay, and then now guys, they want us to find the maximum volume, right? Remember that volume is just equal to 1 over 3 pi r squared multiplied by the height. That's 1 over 3 pi, and then our r squared, guys, we found it to be equal to 150 minus x squared. That's 150 minus x squared multiplied by x. So that's 1 over 3 pi, and then I'll have 150 minus x squared. X is just 5 root 2 all squared, and then multiplied by 5 root 2. We must just leave our answer into 2 decimal places. That's 1 over 3 pi multiplied by 150 minus x squared, and then multiplied by x, which is just 5 root 2. So our final answer, guys, it's basically equal to 740.48 cubic centimeters. This will be our maximum volume. That's how, guys, we could have tackled this question over there. So please, guys, do stay tuned and wait for more videos. Thank you.